Welcome. I am Professor Manivannan from IIT Madras. I'm going to be the overall coordinator for this course. Biomechanics is a highly interdisciplinary course. It involves not only engineering but also medicine. That is the reason we have coordinators from CMC Vellore, IIT Roorkee, and MNIT. In this course, half of the course we are going to focus on the fundamentals of biomechanics. In the other half, we are going to emphasize on the applications of this fundamental aspect of mechanics. The way we want to teach this course is quantitative analysis of this course. Instead of descriptive, we want to give you a quantitative analysis using the models and simulation. That's a real engineering of this biomechanics course. Not only we want to give you the quantitative analysis, but also we want to give you an idea about how do we measure practically several biomechanical parameters and then use it in several biomechanical applications.
I will give you a simple example. When you see me standing on the floor with both, the center of gravity of my body has to pass through the base of support, which is the area contained between my 2 feet. And in this case, all my weight is borne primarily by my bones, the skeleton. Things change when I lift one leg off the ground like this. When I lift one leg off the ground, the pelvis tends to tilt down because one side of support has gone away. And to prevent the pelvis from tilting, the muscles on my right side have to become active to support, to produce a counteracting moment. And when you do the calculations, you will see the amount of force that the muscle has to produce. The distance from the center of gravity to the center of the joint horizontally is about 15 centimeters. And the distance from the center of the joint to the origin of the muscles that support my pelvis is about 3 centimeters. So we have a factor of about 5. And if my body weight is 60 to 70 kilograms, the muscle has to produce a compensating moment, and therefore the force that the muscle has to produce is about 300 kilogram force. And this is something that we would like you to be able to calculate as a matter of routine after you go through this course.
I am Dr. V.K. Katiyar, Professor of Biomechanics in IIT Roorkee. I have to discuss especially the sports biomechanics as an application of biomechanics. The sports biomechanics is really in two concepts we can go through. For athletes, the breathing mechanics and the muscle mechanics. Breathing mechanics, we have go through especially the breathing pattern, the lung function, and its lung capacity, and the muscle mechanics we have to go through for the strength of the muscle, how the movement, how the rotational movement, how the linear movement, and what is the capacity, the power of athlete, which is very much discussed in all the parts of the biomechanics.
We will be talking about the fundamentals of biomechanics, including upper and lower extremities, and we will also be discussing the application of clinical and occupational biomechanics with a special focus on teaching and learning pedagogical perspectives.
After successfully completing this course, the participants will be able to understand and solve quantitative problems of biomechanics. They will also understand the practical measurement techniques. This course will help them to undertake and execute real-life biomechanics research projects in collaboration with various industries and research organizations in India.